All right, for this page, we've got evaluate and simplify to begin with. So remember, evaluate means that you're trying to find the exponent that's on the result. So natural log of e to the fourth is just 4. What exponent is on 1 over e to the fifth? The natural log of 1 over e to the fifth is -5, so this is minus -5. And the natural log of 1 is 0 because e to the 0 equals 1. So 4 minus -5 is actually 9. So that's simplifying that expression. For number 5, remember, it's not just 3 plus 4. You can't cancel right now. You have to condense first. So condense these two logs with multiplication. This becomes e to the natural log of 12. E and natural log cancel out, and your answer is just 12. Because I can't, for number 6, because I can't evaluate these individual logs, I can use change of base. So remember, that means you can make this log of 9 divided by log of 5, or natural log, either way. And this one can be log of 25 divided by log of 9. And this allows you to cancel out the log 9s. So now you're left with log of 25 over log of 5. But the problem is not finished. Now use what I'm calling reverse change of base. So what does that mean? That means go from the fraction back into the log base. So log base 5 of 25, and that answer is 2. For the next one, kind of the same idea. We just did this in number 6. So you're not allowed to say, I'm going to reduce 7 over 49. We never are allowed to just cancel logs. That's not a thing. But we can do reverse change of base. Okay, so that means that this can be the natural log. Oh, sorry, not the natural log. That means this can be the log base 49 of 7. And so 49 to what power equals 7? That answer is 1/2. So it's not 1/7. I'm not canceling or subtracting anything. It's change of base. What about this next one? I have a log base 2, and 32 is 2 to a power. So start working on this a little bit. Simplify using exponent rules. So this is the square root of 32 to the 4th. So 32 is 2 to the 5th to the 4th. Log base 2. Now you can pull the square root out in front with a 1/2, or you could say this is the square root of 2 to the 20th. Or back here, square root of 32 to the 4th is 32 squared. So either way, when I square root something to the 20th power, it's the same as saying you're going to raise it to the 1/2. So now that's log base 2 of 2 to the 10th. Excuse me. And the log base 2 of 2 to the 10th is just 10, because the log base 2 cancels with the base 2. What about number 9? I can't individually simplify or evaluate right now, but if I'm subtracting two logarithms, I can condense them because they're the same base. So 100 divided by 4. And that's just the log base 5 of 25. And that, again, is 2. For my next one, natural log of e, so that's 1. Natural log of 1 is 0. Log of 1 is also 0. So this is 1. For number 11, I don't want to condense these logs first, because in number 9 I condensed because I couldn't evaluate each term, but I can evaluate each of these because remember, common logs are base 10 already, and you're just counting zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the log base 10 of 10 to the 9th is 9. And on this one, this is the log base 10 of 10 to the 4th. You don't have to rewrite it for a test or anything, but it's 9 plus 4, which is 13. And this last one, so e to the natural log of e to the 5th, you can cancel out the e to the natural log, and you're left with e to the 5th. That's one way to look at it. Or you could have simplified natural log of e to the 5th is 5, so then that, again, would just be e to the fifth. Let's go ahead and work on the true and false for this video as well. Let me see what's next. Yeah, I'm gonna take this video through to number 23. Okay. True or false? So this is really a test of, do you remember the expand and condense rules, and can you apply them to see if it's a true statement or not? So you don't have to explain or come up with counter examples, but you're just looking to see, like, pick the side that you know a rule for and see if it matches the other side. So we have a rule for this side, which says we can condense this into natural log of x divided by y, but that's not the same as natural log x divided by natural log y. So this is false. For the next one, you can work on either side. It doesn't matter. I can expand this side into natural log x plus natural log y, and that is the same as natural log y plus natural log x. They've just switched the order, so that is true. Okay, for this next one, maybe I'll expand the right side because that looks more familiar. So this fourth root can be a 1/4 out in front. And then I can expand the x times y into addition. Now the 1/4 would go along with it. So it would be like 1/4 times log base a of x plus log base a of y. And take a look at what you have on the left side. That is the same thing. Multiplying something by 1/4 is the same as dividing it by 4. So whether you say you're going to add the log x plus log y and then divide it by 4, or whether you say you're going to add them and multiply by 1/4, same thing. So that's true. True. There we go. Okay, the next one is false. I don't have any way to expand addition in a log. And if I were to expand or condense the right side, it would be natural log of x times y, not x plus y. So this is not the same. So this one is false. For the next one, let's work on, you can either, again, work on either side, work on expanding or condensing. Now this one is weird. This square root is over the entire natural log, so that's kind of tricky. Where should the square root be? So let's work on this one. This would be 1/2 of natural log times 1/2 times natural log of x on top, y's on the bottom, z's on top. So I agree with the fraction part, but where does the 1/2 go? Does it go out in front of the natural log? No, it goes inside of the natural log. All of this is underneath the square root. That is not the same as the square root of natural log of xz over y. So this is false. And just to color coordinate things, let me fix this, because so far the trues have been blue. There we go. Oops, a little bit got knocked out. Okay, so just fix that. Okay, what about the next one? If log base a of x equals log base b of y, then x equals y. Be very careful on this one. This is only true if these are the same exact base. So that is false. If they were both the same base, it would be the one-to-one property, which is true. All right, what about the next one? So number 19, let's expand out the left side. It would be log base a of a minus log base a of b. Now they have 1 minus log base a of b. So where's this 1 coming from? That's from simplifying. What is log base a of a? That is 1. So yeah, this is true. All right, last one of the true or false. Natural log of x minus y, does that mean natural log x minus natural log y? Nope. We don't have any way to expand this. We don't have any rule for that. We only have rules for x times y, x divided by y, and x to a power. This right side could be log base y of x. It could be change of base, but it's not that. So false. All right, let's finish this video with this last section since it's related to expanding and condensing. So for these problems, rewrite each expression in terms of a, b, and c, where a is natural log 3, b is natural log 4, C is natural log 5. So the general steps here are expand. And then if the numbers are not 3s, 4s, and 5s, then you need to rewrite the numbers. If there's anything you can simplify or evaluate, you do that too. After you rewrite the numbers, you're going to need to expand again. And once you have everything fully expanded in terms of natural log 3s, 4s, and 5s, then you can sub in letters. So there should be no natural logs left in our final answer. So let's take a look at 21. So expand first. Natural log of 15 minus natural log of 16. Step 2 is rewrite these numbers so they're in terms of 3s, 4s, and 5s. Like, and order doesn't matter. 15 is 3 times 5. And 16, I've only got these choices, so I'm going to say it's 4 squared. Okay, now step 3, expand again. So this is natural log of 3 plus natural log of 5. And how do I expand something with an exponent? I pull the exponent out in front, so it's minus 2 natural log of 4. Fourth step is to sub in your letters. So natural log of 3 is capital A, plus natural log of 5 is capital C, minus 2 times natural log of 4 is B. Okay, so let's repeat those steps for 22. So expand first. Natural log of 60 minus natural log of the square root of E. Rewrite 60. 60 is 4 times 15. So 60 is 4 times 15 is 3 times 4 times 5. You can write those in any order. And then what about this? Natural log with a base E, you can simplify that to a number. Evaluate that natural log. What's the power on the E right there? It's a 1/2. So instead of minus natural log square root E, I've evaluated that and it's minus 1/2. Step 3 is expand again. Natural log 3 plus natural log 4 plus natural log 5 minus 1/2. Step 4 is replace with the natural logs with their letters. So capital A plus capital B plus capital C minus 1/2. All right, next one, expand first. So natural log of 12, separate this out, plus natural log of E minus natural log of 225. Now 225 is 15 squared. And 15 squared is, we don't have 15, we have 3 times 5 squared. So I'm going to be using that to rewrite this. 12 is 3 times 4. Natural log of E can be evaluated. What power is on that E? 1. And like I said, this is the natural log of 15 squared, or let's make it 3 times 5 squared. And then let's expand this out some more. So this becomes natural log 3 plus natural log 4 plus 1. And then this is minus 2. So you bring this 2 out, and then you're going to expand again. So 2 times natural log 3 minus 2 times natural log 5. So when I expand that with addition, the minus 2 gets distributed through. And then there are a couple of like terms here, like ln3 minus 2ln3. That can be combined. So let me bring this up here. So 1 minus 2 is negative ln3 plus ln4 minus 2 ln5. And then there's a plus 1 in there, so plus 1 at the end. Again, the terms can be written in any order. And then that would be negative A plus B minus 2 times C plus 1. All right, I'm going to stop this video here. And then the next video will be the identifying your functions and solving your equations.